Before we look at a particular quadrilateral, I want to introduce everyone to the entire quadrilateral family. Okay, these are all the quadrilaterals that we'll be spending a day or two or three on focusing on their properties. So right at the top here is the quadrilateral. You will see that it is broken up into three what I call families. All right, three different families for the quadrilaterals. And I'll show you why we broke them up into three in particular at the end here. But just let me introduce you to everyone. All right, for this first family right here, first figure, Papa parallelogram. There we go. That'll be the last time I write the word parallelogram. Here's how I abbreviate it, and you are allowed to abbreviate on any of our homework, tests, quizzes, midterms, Regents exams. All right, a little shorter version. Please do not be embarrassing and say, what did you mean by 11-ogram? Nope, it's parallel, the symbol for parallelogram. Okay? Oh, yeah. If I didn't say that, somebody would have said that here. Let's be honest. 11-ogram? What's he mean by that? All right, anyway. And then the rest of the family. We have Rosie, the rectangle. Randy, the rhombus. And then finally, the golden child of the entire family, Susie. Susie, the square. Okay. Everybody good? And don't give me this weird, awkward that you see, oh, wait a second, the two kids and then all of a sudden the square came out of that? That's not how it works, all right? We're not rolling that way, all right? We're not rolling that way. All of them are all kids in the same family, all right? Calm it down. All right, moving on. Second family in the quadrilateral family is the trapezoids. We got Tony here, the trapezoid. And I don't know what the relation is to the next one, but it's Isaac, the isosceles trapezoid. And then we have the last one, the outcast, the black sheep. Some of you will have something in common there with it, all right? You can relate to our last buddy here, which is Kyle, the kite. Okay. Now, why do we break them up into three families? Here's why, guys. Here's why. Every single one in the parallelogram family has both pairs of opposite sides are parallel. Okay? Both pairs. Opposite sides parallel. In the trapezoid family, only one pair. All right? Only one pair of opposite sides are parallel in the trapezoid family. And with the kite, sorry, got nothing for you. All right, so that's why we do group them in the groups of three like we do have up here. Grab the three groups. Both pairs of opposite sides parallel, one pair, no pair. Okay, everybody good? Because now today, Monday, Tuesday, and Wednesday, all dedicated to a parallelogram. Today, properties in algebra, Monday, Tuesday, Wednesday, proofs using them. Okay, let's do this. And I know I'm actually shocked no one has called me out that I've been jipping you on the page turn effects because I've usually been over there, so I just click on the next one, but I'll get back to it now. All right, I'll get back to it. Okay. All right, properties of a parallelogram. Before I mention any properties, triangle, you didn't have to worry about how you labeled it. You just put the vertices wherever the heck you wanted. It does matter how you label a parallelogram, though. Okay? So let's call this parallelogram ABCD. You cannot throw the A, B, C, D anywhere you want. Okay? So go ahead, put the A anywhere you want. That's fine. Start at this out. Any vertice you can call A. But now you either have to go clockwise or counterclockwise to finish the labeling. You cannot jump diagonally on a quadrilateral when you label it, okay? Because that'll throw off where the diagonals are and everything, okay? So you either can go clockwise or counterclockwise to label it. It's up to you, but do not jump diagonally, please. All right, 5 properties you're going to be responsible for. You guys already know one property from the family tree, and that is what? Opposite sides are parallel. There we go. Opposite sides are parallel. And let's start labeling our parallelogram with these facts. So parallel, 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 parallel. So opposite sides parallel. Now that means we dedicated a full unit to this a couple units ago about parallel lines. Anybody remember the special types of angles that are formed by parallel lines? Not necessarily in this diagram, but just what were the vocabulary terms in general? Mike? Okay, so we better start watching out for alternate interior. We should also start watching out for corresponding, same side interior. Now that these are parallel, I'm going to have different types of angles here. Next up, not only are the opposite sides parallel, but they also are congruent. Opposite sides are congruent. So DA congruent to BC, CD congruent to BA. Anybody know any other properties? I might as well, you can drop some knowledge, show your power here. What's up, Sean? Look at this kid, huh? We call those opposite angles. Opposite angles are congruent. Nice job. By the way, did we get a fresh cut lately? Nice. Professional, homegrown. Is this the first time I'm asking somebody in this class? Oh, professional is obviously somebody did it, but homegrown is you did it either by yourself, which I've had in the past. My one kid in my first period class has cut his own hair. And then, or somebody at home did it. Professional, do you approve of it? Now, here's my other question I always ask with haircuts is, do you get the say, or does somebody else tell you how it's going to get cut? Okay, all right. So you're good with how it came out? So you're good how it came out? Not bad. I think decent. It's decent. Okay. All right, moving on. So let's label our opposite angles. Congruent. So D congruent to B. Angle C congruent to angle A. Now, we learned yesterday how many degrees are in every quadrilateral? 360. Wow. Can you tell me then if all the 4 angles add up to 360, the opposite ones are congruent. Can you tell me anything about D and A and B? The ones next to each other, what do you think? They're not congruent, but if they're all going to add to 360, they should be supplementary. And what I call those angles are consecutive angles. So consecutive angles are supplementary. And the final property that you're going to be responsible for any parallelogram, just help me out right now. What am I drawing in? Diagonal, good. And a second diagonal. I'll put the markings on them. You tell me what they do. Not bisecting the angles. Bisecting each other. Good, Mike. Diagonals bisect each other. Oh, we're not done. I want to put a little note behind diagonals bisect each other. If they do bisect each other, what's this point right here on both diagonals? That's the midpoint. Everyone agree? Because a midpoint cuts it into 2 equal parts. So that means that the diagonals also share the same midpoint. Yep. So whatever the midpoint is of one diagonal, it is the same midpoint of the other diagonal. Questions? All right, let's put all this to work now. Let's put it to work. Find the value of x. Oh, and there's that term, there's that little directions again. Justify your answer. So tell me why it is what you think it is. All right, here we go. Number one, we got this piece of the diagonal is 10. This piece is 2x minus 4. What property can I apply of a parallelogram here? All right, let's go back to our trusty numbers. Oh, boy, not working here for me. All right, I see you. Okay, want to play that way? What can I do with those two? Justin, go, and we'll go around the room. Why are you setting them equal to each other? What's the property you're trying to apply here?
The diagonals separate them into the congruent. It's like the midpoint thing.
It's right on the previous page.
Diagonals bisect each other.
Diagonals bisect each other. So these two pieces are equal. Justin needs somebody. Let's go call on somebody since the numbers aren't working. When you get X, Nick, let me know. 7. Here comes the justify part. I want you to start doing it now because on Monday, these justifications are going to be in your reasons column when we start a proof. All right? What property did you apply? And you knew you could apply that a property because this is a? No. This just the figure. Okay, so here's what we're going to write. Parallelogram implies, there's that arrow we've used in the past. What property, Justin? Diagonals bisect each other. Okay? So get used to that because that's what we're going to start putting in the proof. So parallelogram implies, give me the property that you used. Nick, let's go. Need somebody. Okay, next one. It's a parallelogram. Thoughts on how I can find x? Okay, this one's a pretty quick one. Nothing to solve. I tried to throw the 18 in there to throw you off. Guess it didn't work. What property are you using there, Nick? So parallelogram implies that opposite sides are congruent. Thank you. Okay, need somebody. Luke, here we go. Number 3. What can I do with the 4x minus 10 and the 3x minus 2? What property are you applying? Okay, so these pieces are equal. 4x minus 10 equals 3x minus 2. Need somebody there, Luke? Whenever you solve for x, Emily, I don't care. Whenever it is, go ahead, take your time. I just want x equals 8. And then again, we applied parallelogram implies diagonals bisect each other. Thank you. Okay, a little bit different for number 4. I tell you this piece of the diagonal is 4x plus 3, but then I told you the entire diagonal has a length of 35. Emily, need somebody. What do you think I can do here, Emma? This piece is 4x plus 3, but the entire diagonal IK 35. So go ahead 2 times. There you go. And I know this is getting a little redundant about parallelogram implies diagonals bisect each other, but we'll get to angles in a second. Emma, need somebody to solve this for me. Whenever you're ready there, Evan, let me know. It does come out to be a decimal, so don't freak out. Nice job. And again, parallelogram implies diagonals bisect each other. And 5. I think I gave you a little too much information there, so don't think you got to involve everything. I'm looking for finding TI. Find the length of diagonal TI. I told you TR 14 and diagonal ME 31. So Heaven, need somebody? Hi. How's it going? I'm doing well too, thanks. Any ideas how I can get to TI there, Will? Okay, what's TR? 14 times 2, so I really didn't even need ME. I just threw it in there to see if anybody would try to use it. 14 times 2 there, Will. Whew, tough one, right? And what'd you use to figure that one out? What property? Okay. Parallelogram implies diagonals bisect each other. Okay, enough of the sides and the diagonals. Let's go to angles now. But here, good news, you do not have to justify your answer. I kind of wanted to see you struggle here. So I'm going hands off. It's all on you guys now in your groups. Talk it over. Now, couple suggestions before you get going. Just don't think in terms of parallelogram, parallelogram, parallelogram. Vertical angles are congruent. Linear pairs are supplementary. Look for, now that you know opposite sides are parallel, remember what we talked about. Look for those alternate interior. Look for those same side interior angles. How many degrees are in every triangle? Use every fact you have, just not parallelograms. I'm going to post the answers up here. Talk it over with your group. If you guys cannot figure out where I got a value from, let me know. Okay, and then once we all match up, you can start on your homework. But do not copy it down. Call me over and ask me how to figure it out. So go ahead, discuss it up. Use your properties and any other geometry you can apply. Do not feel either that you have to go in number order. Whatever angle you can find it. Maybe it might be an angle that's not you're not supposed to find. Okay, find it. Maybe it'll help you find one that you that's numbered already. Right? Don't feel like you have to go in number order. Maybe find an angle that's not labeled. That might get you to a labeled angle. So I'll leave these up here. Let me just stop everything.